we need to find the complete integral of these two differential equations. So first we have this part. This equation can be written as, because we know that P is del z by del x and Q is del z by del y, right? So we can write this equation as, let me name this as 1. I'm having z the power 6 over here. Let's divide all over z power 6 equals to 1, right? And let's take the cube of p⁴x divided by z square, and let's take the square of z²q²cosec⁴y divided by z the power 3. We are taking the square of this equals to 1. Writing this p as del z by del x, and the sec²x is 1 divided by cos²x, and writing this z² to be in the numerator z power minus 2, and it is having the cube, plus this z is cancelled out with this, having the power 2 over here, and it is z power minus 2. Cosec²y can be written as, it is divided by sin²y, and this q is then del z by del y, and it is having the square equals to 1. Very fine. Okay. Till now, from the previous questions, we are taking the value of u, v and w. We are considering the values of these, right? But in this example, we are considering what is du, dv, dw. That is the differentiations of u, v, w. We can also take the differentiation of these two variables. But in this example, we can also consider the differentiations of these variables, right? So for that, let me take this complete denominator to be du and this complete denominator to be dv, and considering this remaining numerator, which is same in both the terms, to be dw. So this is dw. So we have considered du to be equal to, it is cos²x dx, dv to be equal to, it is sin²y dy, and dw to be equal to, it is z power minus 2 dz, right? So when integrating this, we are getting the value of u to be equal to, if I take cos²x to be 1 plus cos double the angle divided by 2, when you integrate this with respect to x, you will be getting, please solve this on your own, you will be getting 1/2 x plus sin x cos x. If I take sin²y to be, by formula, it is 1 minus cos double the angle divided by 2. So when integrating this, we are getting, by symmetry, it is 1/2 y minus sin y cos y, right? So from here we are getting w to be equal to, when integrating, we get, it is minus 1 divided by z. So we have got our three values of u, v, w in terms of x, y, z. So let's get back to the given equation. This given equation is rewritten as this. So let me write this equation again. We have here cos²x dx in the denominator, that is du. So it is dw by du. We have in the numerator dw, and in the denominator we have du, right? So it is dw by du the power 3. And from the second term we have dw divided by dv. You must write here del w divided by del u, because we are partially differentiating w with respect to u, because here w is depending upon u and v, right? It is depending upon two variables. That is why we have to write here the partial derivative of w with respect to u, right? So the second term is partial derivative of w with respect to v. You cannot write this sign dw, because dw by dv, you cannot write this d, you have to write this del. Del means it is partially differentiating. W is depending upon u and v both. So this is del w divided by del v and the square. So it is equal to 1. Let me consider this to be the capital P and this to be the capital U. So we have p cube plus q square to be equal to 1. Now we have got the equation in p and q only, right? Our aim is to get the equation in terms of fpq, and here we have considered the capital P and capital Q. So our equation is in terms of capital P and capital Q, where capital P is del w by del u and capital Q is del w by del v, right? What is the next step to solve? We always take P to be the constant. Let me take this P to be equal to A, so that we can get Q to be equal to 1 minus A square under the root, right? And now our second step is to integrate what equation? dw to be equal to capital P du plus capital Q dv. So putting the values of P and Q, so it is A du plus 1 minus A square under the root dv, and now integrating. So we have w to be equal to au plus the square root of 1 minus A square v, it is constant, plus the constant b. B is constant, A is also constant. And now we are going to put the values of small u, v and w. It is minus 1 by z, v is this and u is this. So w is minus 1 by z equals to a into what is u? It is 1/2 of x plus sin x cos x. Yes. Plus the square root of 1 minus A square. What is v? It is 1/2 of y plus sin y cos y plus b. You can also rewrite this equation as, I'm writing the right hand side first, it is a into x plus sin x cos x plus the square root of 1 minus A square. Sorry, this is a cube. It should be a cube. Just wait a minute. It should be a cube because we are having cube over here. This is cube. So if p is equal to a, this should be 1 minus a cube, right? 1 minus a cube under the root. I'm very sorry for this. So this is a cube. Square root of 1 minus a cube, y plus sin y cos y plus twice of b, plus if I take minus 1 by z to the right hand side, we have 2 divided by z to be the equal to 0. So this is the required complete integral, is the required complete integral. We have x plus y over here and x minus y over here. So it is very easy for me to take x plus y to be, let me take this as u square and this to be as v square, because we are having square over here. So that is why I have also taken this squares on u and v. So let's take x plus y to be equal to u square and x minus y to be equal to v square, and because we know that p is del z by del x and q is del z by del y. So let's consider del z by del x because z is depending upon both x and y. So this is equal to, this is del z by del u and del u by del x plus del z by del v into del v by del x. Del z by del u, as it is we cannot find this, and del u by del x, from this we get, from here we have, if we differentiate both the sides with respect to x, we get 1 plus 0 equals to 2u del u by del x. So del u by del x will be 1 divided by 2u. Similarly, del z by del v could not be found out. So del v by del x, from here we have this to be again 1 divided by 2v. So let's take this to be capital P and this to be capital Q. So P, that is del z by del x, is equal to, it is capital P divided by 2u plus capital Q divided by 2v. Similarly, we can find Q to be equal to del z by del y, that will be equal to P divided by 2u minus Q divided by 2v. Similarly, in the similar way, you can try this. Putting the values of P and Q and this x plus y and x minus y back to this equation, given equation. What is x plus y? It is u square. So from the given equation, x plus y is u square, x plus y is u square into p plus q whole square. That is, if I add these two, we have these two cancelled out, we have twice of p divided by twice of u and its square. 2 cancelled out. Okay, u square is also cancelled out with this. We have p square only over here. So we have p square plus, similarly x minus y is v square and p minus q whole square. So this is v square, and subtracting these two we get minus twice of q divided by 2v and its square. So 2 cancelled out, v square is also cancelled out with this. We have plus q square, capital Q square, equals to 1. Right? Again, from here, now taking capital P always equal to the constant a, we are getting the value of q to be 1 minus a square under the root. Yes, it is square. And now integrating dz to be equal to capital P du plus capital Q dv. There is no w, so we have to write dz over here. If you have considered your w, then you have to write dw over here. In the previous example, we have written dw instead of dz, right? Because here we have only considered two values, u and v. Sorry, u square and v square, means two variables. So for two variables u and v, we write dz. For three variables u, v and w, we have to write dw to be equal to p du plus q dv. Understood? Okay. So putting the value of capital P, that is a du plus, it is 1 minus a square under the root and dv. Integrating, we get z to be equal to, okay, a u plus the square root of 1 minus a square v plus the constant b. And now putting the values of u and v over here. So this is z equal to a. What is u? We have u square to be equal to x plus y. So what is u? It is the square root of x plus y, right? plus the square root of 1 minus a square. What is v? We have considered v square to be equal to x minus y. So what is v? The square root of x minus y plus the constant b. So this is the required complete integral. Is the required complete integral. Alright, thank you. Stay blessed. Have a very nice day.